Welcome back. We're ending Module 1 with parenteral nutrition, one of the most advanced math skills on the ID exam, but very manageable through the use of dimensional analysis, percentages, and equivalent statements. You can do this. But it's important to understand the major differences between enteral nutrition, EN, and parenteral nutrition, PN. Enteral nutrition is used when a patient cannot meet their needs orally, but they still have a functioning GI tract. This is tube feeding, and it's generally preferred because it maintains gut integrity. It supports the microbiome and it lowers complication risk. Parenteral nutrition, on the other hand, is used when the GI tract is non-functional or unsafe to use. In those cases, the nutrients have to be delivered directly into the bloodstream. Because parenteral nutrition bypasses digestion completely, the cost and risk of complications goes way up, as all of that nutrition is now delivered intravenously or by an IV. This means precision in parenteral nutrition becomes critical, and we have to make sure that the formulation is safe. This can feel intimidating at first, but we're going to take it step by step. In this first video, we'll just look at how nutrients are calculated from an order and think through how proper PN orders can provide adequate nutrition to those with no other option. We can break parenteral nutrition into its two forms, TPN and PPN. Each serves a different clinical purpose depending on access, nutrient concentration, and duration of support. For longer-term nutrition support, where central access to the heart is possible, we provide nutrition through total parenteral nutrition, or TPN. The central access veins are larger, so it's much more likely to meet the patient's nutritional needs. Though if we don't have central access, if we only have access to a peripheral vein or a small vein, then we would use peripheral parenteral nutrition, or PPN. But when we have peripheral access, we need to be careful with the type and quantity of nutrition that we are feeding. Milliosmoles per liter, this unit right here, is a unit to measure osmolarity, or the concentration of solute particles in the solution. It tells us how concentrated our solution is, how much nutrition is in our solution. And the higher the milliosmoles are, the more particles that are dissolved in each liter of fluid. Peripheral parenteral nutrition has an 800 to 900 milliosmol per liter limit. Because these veins are smaller, they're more delicate than the central veins, which makes them sensitive to irritation or damage from hypertonic solutions. And we'll talk about how to calculate this. But first, we actually need to talk about the two different types of parenteral nutrition feeds. A 3-in-1, or total nutrient admixture, combines amino acids, dextrose, and lipids into one bag. This simplifies administration and allows the nutrients to be calculated as percentages of the total volume. A 1-to-1, also known as a 2-in-1, or a piggyback system, combines the dextrose and amino acids, while the lipids are administered separately. This means lipid calculations must be handled independently. But besides that, the calculations work exactly the same. And remember, in both TPN and PPN, nutrient concentration and osmolarity have to match the access route for safety. The good news is these calculations mainly rely on percentages and dimensional analysis, using nutritional composition as equivalent statements. So the final thing we need to review before working through an example is the nutrient contributions of each macronutrient. So when we administer carbohydrates in parenteral nutrition, we do that through dextrose. Unlike typical carbohydrates, dextrose has only 3.4 calories per gram. A typical gram of carbohydrates has 4 calories per gram. You absolutely need to have this memorized for success on parenteral nutrition calculations. Now, how we infuse the dextrose is given as a percent. If it tells you D15, then that means we're giving 15% dextrose. And we know what percent means. It means per 100. So 15% dextrose is 15 grams of dextrose in 100 milliliters of water. And this right here is an equivalent statement. So if we know the volume of nutrition that's being provided in milliliters, we can figure out how many grams of dextrose that is, and then using the amount of calories per gram as an equivalent statement, we can convert from grams to calories of dextrose provided by our solution. So if we had D10, again, D10, that means 10%. 10 grams of dextrose in the 100 milliliters of water-based peripheral nutrition solution. For amino acids, this is nice and simple, same as regular nutrition. 1 gram of amino acid has 4 calories. Worth knowing, it's an equivalent statement that you will use in these calculations. And like dextrose, we list the amount of protein as a percent. So let's say our recommendation says 4.5% amino acids. That's 4.5 grams of amino acid in 100 grams or 100 milliliters of water. So to write it the same way, to say 4.5 grams of amino acid is the amount of amino acid in 100 grams, which is 100 milliliters of water. Since those two things are equal to each other, we can write it as a fraction as I have written it here, 4.5 grams of amino acid per 100 milliliters of water, or flip that upside down and say 100 milliliters of water has 4.5 grams of amino acids. When it comes to fat in parenteral nutrition, you might remember that intravenous lipid emulsions have glycerol for osmotic purposes. This adds additional calories beyond the standard 9 kcals per gram of fat. Because of this, IV emulsions have approximately 10 calorie per gram of lipid, and so we can use simplified equivalent statements for calculations. A 10% IV lipid emulsion contains 10 grams of fat per 100 milliliters of solution, which is approximately 1.1 calories per milliliter. A 20% IV emulsion has 2 calories per milliliter, and a 30% IV emulsion has 3 calories per milliliter because, again, there's 10 calories per gram of lipid. The 10% solution is the only slightly unusual one because its lower fat concentration means that the glycerol contribution is proportionally more significant, which raises the calorie value oh so slightly above what is initially expected. For the RD exam, the key takeaway is this. IV fat emulsion provides about 10 calories per gram as opposed to the standard 9 calorie per gram rule, since these values need to account for the glycerol. So when we're trying to determine the nutrition provided by our parenteral nutrition, the lipids are usually measured in milliliters, and dextrose and amino acids are always measured in grams per day and represented with a percent. These equivalent statements are used in every TPN calculation, so make sure that you are comfortable with them. And let's get into the 3-step process for how to determine the nutrition. Just like we did for enteral nutrition, we're going to break down parenteral nutrition calculation into 3 clear steps. The first thing that we're going to do is to determine the daily volume. So we're going to look at the infusion rate, assuming it's continuous, multiply it by 24 hours or the number of hours that it's being administered every single day. Once we know our goal volume or the ideal volume provided, we can then calculate the daily nutrition. So we're going to focus in on the grams and calories of each macronutrient here, because once you know how many calories come from each macronutrient, we're going to add them up to get the total. So let's try ourselves a TPN problem step by step. A nice simple one. Determine the nutrition supplied by the TPN order that's got 1.5 liters of D15, 4.5% AA, and 2.35% lipids. To solve these problems, we do the same 3 steps. We first want to determine the daily volume provided by the order. And in this problem, we know that we're giving 1,500 milliliters a day of our parenteral nutrition. Once we know the goal volume, we can figure out the nutrition provided from each macronutrient. This right here, this is my goal volume. For carbohydrates, we need to convert the volume into grams of carbohydrate. Since it's D15, that tells us that it's 15% dextrose, or 15 grams of dextrose in every 100 milliliters of solution provided. So if we have 1,500 milliliters of solution provided, then we're getting 225 grams of carbohydrate, and this carbohydrate is dextrose. If we can remember that there's 3.4 calories in every gram of dextrose, then we can convert from grams of dextrose into calories from dextrose. Every day, if we give 1,500 milliliters of this solution, 15% dextrose, that's 765 grams from dextrose every single day. We're going to repeat this for our amino acids here. It's 4.5% amino acids. So that's 4.5 grams per cent per 100, which means this patient would be receiving 67.5 grams of amino acid every day. Since there's 4 calories per gram, that's 270 calories from amino acids every day. This patient is also, this is a 3-in-1. This is not being hung separately. We have a 2.35% lipid here out of the 1,500 milliliters of solution. That's 35.25 grams of fat every day. Lipids provided in TPN have 10 calories per gram. So this patient is taking in just over 325.5 calories from fat every day. And so since we know all of the energy provided from each macronutrient, we'll add them up to determine total daily calories. Given this TPN order, the patient is receiving 1,387.5 calories in a day, assuming the TPN runs continuously and without interruption. Let's try another, but this one is a piggyback. I highly recommend you pause and try it on your own. It says to determine the nutrients supplied by the TPN order of D20 with 5% amino acids running at 75 milliliters an hour. In this case, we have 500 milliliters of the 10% IL hung separately 4 times a week. You can solve all PN problems using the same 3 steps, but you first need to know the total daily volume that's provided by the order. The problem doesn't say if the TPN is continuous, but it's implied, and the nutrition is infused at 75 milliliters per hour. So to find the total goal volume infused each day, We'll use the equivalent statement of 24 hours in a day, which tells us the patient is receiving 1,800 milliliters of the TPN solution every day. That is our daily volume provided by the order. The next step is to figure out the amount of calories from each macronutrient. And we do that using percents. So for dextrose, this is D20, which means that's 20% of the solution is dextrose. We're giving 1,800 milliliters of solution, and since it's D20, that means 20% or 20 grams of carbohydrate per 100 milliliters of solution. So that's 360 grams of dextrose every day. Now we need to remember that there's 3.4 calories per gram of dextrose. So if we're giving 1,800 milliliters of this TPN solution, that's 1,224 calories from carbohydrate. It's also 5% amino acid. So we're going to do the same thing. 5% amino acid is 5 grams of amino acid in 100 milliliters of solution. And we're giving 1,800 milliliters of solution, which means we're giving 90 grams of amino acids. Amino acids have 4 calories per gram, so that's 360 calories from the amino acids every single day. The lipids provided are 500 milliliters of 10% intravenous lipid emulsion 4 times a week. You should recall that in 10% IL, there's 1.1 calories for every 1 milliliter of that solution. Since 500 milliliters of lipids are provided, we can use this as our equivalent statement. 500 milliliters giving slightly more than 1 calorie per milliliter is equal to 550 calories from fat. At 10 calories per gram of PN lipid, we're providing 55 grams of fat in this solution. Though this patient only receives lipids 4 days out of the week, they aren't getting daily lipid infusions. The 550 calories are given 4 days out of every 7 days. 1 week is 7 days. So we can write an equivalent statement that says the patient is receiving lipids 4 days in 1 week, which is 7 days. This conversion is letting us estimate how many calories they're intaking from lipids every day. So at 550 calories provided 4 days out of each 7, we find out the daily approximation of lipid is 314.3 calories. And so now that we've figured out the calories from dextrose, from amino acids, and the approximate calories from fat, we can determine the total calories here by adding up all the macronutrient energy contributions, coming to 1,898 calories provided daily by this TPN order. As we approach the end of Module 10, just one more video to go. I don't want you to feel rushed. I want you to feel supported. All parenteral nutrition problems that ask you to determine the nutrition provided can be solved using percents and dimensional analysis. Take your time identifying your variables, setting up your equivalent statements, and following the units through. Clinical dietitians do these calculations all the time, and so can you. Bring any questions into the comments and get the support you need. And I will see you in the next one, the last video of Module 1.